Hi all, welcome to my channel, and this is a continuation of design patterns playlist. I have already covered creational design patterns. If you didn't watch my creational design patterns, you can go. I'll put all my links in description. You can go and watch. And today I'm starting structural design patterns. So now let's talk about adapted design pattern. That is the first design pattern among structural design patterns. Now before going to adapted design pattern, let's talk about some small problem. This is the problem commonly occurs in when we are in railway stations or when we are in airports, so where they basically wants to charge your mobile with the help of charging pin, and you'll go near the charging port. Suddenly you'll feel different kind of behavior. What is the behavior? Like your charging pin might not be fit into the particular charging port. Why? Because both are two different configurations. So what you will do in this case, the first thing is you will check for alternatives. You will ask all the persons who are sitting around that particular charging port and ask hey people, I have my charger has this configuration and the charging port looks like different configuration. Did anyone have a adapter or a converter which acts as a middle person, so that I can put my charging pin into the particular adapter, and I can put the adapter into the charging port so that I can be able to charge. So that is the alternative you will look for. That particular middle object is basically called as adapter. Now let's see the standard definition, and then I'll walk to the Java code. So adapter is a behavioral design pattern that allows objects with incompatible interfaces to collaborate. So these two are incompatible interfaces. Adapter is basically helps to collaborate. So before going to that, I will explain with a small example. So I'm a client. I want to call a request to the particular vendor. You can call it a server also. So I only know JSON. So I serving request in a JSON format. I was posting data. But what happening at vendor side is vendor only handles XML request. So vendor replies, who are you man? I won't support these. If you again call me, I will block you So basically what exactly this means, vendor not able to recognize the what you're asking, the object whatever you're sending, right? The vendor not able to recognize, because vendor only able to recognize the XML data. So simply it will reject your request. Now as a problem solver, as a programmer, what you will do, let's see. So as we are problem solvers, so what if you write a piece of code which will convert JSON to XML, so that I can so I'll write a class where I'll pass the parameter is basically JSON, and the return type is basically XML. That solves my problem, right? That's nothing but adapter. So here is the improvised code, improvised version of diagram. So first the client, me, calling to the adapter, asks to convert vendor supported format. So adapter basically replies with the vendor supports format. Then client will basically post the data to the vendor. So that vendor, so client, we are posting the XML request. So finally vendor recognizes our request and reply with the particular response. So this is a small diagram about how the adapter patterns work. Among all the structural design patterns, adapter is something very easy to understand. Let's go through some of the types of adapters, and we can go through a code walkthrough. So adapters are basically two types. One is class adapter, and second thing is basically object adapter. Class adapter requires basically inheritance, which doesn't support Java, and also it is against the principle of composition. So we should use composition over inheritance, right? That's why for now we are using the object adapter. The example which I discussed just now, which is nothing but an object adapter. So there are two incompatible objects, XML request and JSON request. We are writing a piece of code to convert each other. So yeah, now let's see the code. So I have a client. Client is basically calling API to vendor. So client has a JSON object. Client simply serves the request. So client simply serves the request. So now I need to write a piece of code that is nothing but adapter. So I have created a class called adapter and implements the client interface, whatever request client is calling, so that client has an argument rate. I can return within a vendor supported return type. So I am taking like a client argument. Now I am converting the client argument JSON object into the XML object. After conversion of XML object, now I am calling to the vendor to server request like. So vendor basically returns the string format, whatever it's so, and if you see client, so client will basically get the data and we are returning like to other clients who are calling us like. So if you see the driver code, right? So first we have a client. So client is basically having a constructor of adapter. So adapter in turn has a dependency on an XML vendor like. So we are using an adapter dependency, adapter as a composition as a client interface here. So this client interface basically responsible to convert into the vendor supported call rate, which means like this client interface should has the vendor dependency like vendor object. If you see the implementation, it has like vendor as a constructor argument like. So once we have XML vendor, we can simply return once after conversion of JSON to XML. So if we execute the code, here we are passing the JSON and we are getting the for the vendor we are passing as the XML and we are returning the string, and the string we are just printing the response of we are printing the response from after API call successful. If you see, we got the response like vendor call made, and this is the data which we got from API. So this is a small example about like adapter design pattern. So in Java, like adapter design patterns uses very commonly, like in every application. Without vendor pattern, nothing was designed. So let's say you can try this one. I will explain after completion of all the design patterns. At last, when we are writing big project like with the help of by using all design patterns like. So we have like different kind of data sources like let's say JPA for relational database, Mongo for NoSQL databases, and Cassandra for it's also kind of NoSQL, right? Like wide column range database. So we have different kind of data sources. Without changing the code itself, like through arguments itself, you can decide. Okay, I want to use the JPA. I want to use the Mongo. You have some particular data. You want to fit the data into either JPA, either Mongo or Cassandra. Here you can use the basically multiple design patterns. Here you can also use adapter. Along with adapter, you can also think about like proxy. You can also think about like strategy design pattern, which I will discuss in future. But you can try if you have time. I think anyway I have shared everything in detail in my GitHub. You can go and watch. You can go and refer the code everything. I'll update this MD file with all the YouTube links, everything, so that you'll get the more understanding here itself. I think that's it for today's tutorial. In the next video, from the structural design pattern, I'll focusing on proxy design pattern. So stay tuned for that video, and please like and subscribe, which helps me to make more videos. For now, we're done for the day.